Welcome back to the channel of Chem Pacific. In this video, I'm going to discuss with you a very important question on the topic of modification of orbital diagram. This is the most requested video because lots of students actually requested me to solve this question. This question consists of a very strong concept. I hope I can make you understand. So before we get started, don't forget to subscribe our channel and press the bell icon. And also if you like our video, to press the like button. Now let's get started. Now the question is, actually this is CSIR-NET December 2011 part C question. Okay, now they're asking that for the high spin and the low spin of D6 octahedral complex, generally observed spin allowed transitions respectively are. Okay, so they are asking for the D6 high spin and low spin. So first of all, let us discuss about the D6 high spin, which is very easy. This is the D6 high spin octahedral complex. So before I start, I hope you must be knowing that the value capital A, it defines when the degeneracy is 1. Okay? When it is singly degenerate. When the value is AE, it is depicting that it is doubly degenerate. And similarly, when the value is T, it means it is triply degenerate. This is triply degenerate. Clear? Now say students, when I'm talking about the D6 high spin octahedral, तो पहले इसका term symbols calculate कर लेते हैं. So this is 0, this is -1, -2, this is +1 and +2. When it is high spin, 1, 2, 3, 4, 5, 6. So the mod value of A will be equal to, which is you are having 2 electrons with the value of -2, you are having 1 electron with the value of -1, then you are having 1 electron with the value of 0, then 1 electron with the value of +2, and then 1 electron with the value of +2. So this will turn out to be equal to, since we are taking the mod value, the answer will always be 2. Now we already know if the value of capital L is 2, you have S, P, D, F, G, H, I. And the corresponding value of L will be 0, 1, 2, 3, 4, 5, 6. तो यहाँ पे मेरा जो value आया है वो है आपका 2. So it will be designated with the letter capital T. So we know very well, since there is number of unpaired electrons n is equal to 4, therefore S, which is equal to 4 by 2, which will be 2. Therefore multiplicity कितना हो जाएगा, मतलब 2s plus 1 कितना हो जाएंगे, 2 into 2 plus 1, which is equal to 5. तो इसका ओवरऑल टर्म सिंबल्स आपका हो जाते हैं 5d. And since it is D6 high spin, so 5d will get splitted into T2G5, this is the ground state term, and 5Eg. So there will be only one transition from the ground state to the one excited state. Therefore the number of transition, there will be only one transition. And it will take place from the ground state T2G to the excited 5Eg. the transition is 1 in the case of the high spin d6. तो ये काफी सिंपल है, ये सबको पता है, लेकिन प्रॉब्लम यहाँ पे है क्या होगा when it is low spin. So next is they are asking for the low spin. ठीक है, octahedral, ठीक है. So d6 complex, low spin octahedral d6 metal ion. So I again repeat. So A means singly degenerate, E means doubly degenerate. When you are having two degenerate orbitals with the same energy level, you denote it with E, and T means triply degenerate. That is why जब d orbital split करते हैं T2G EG, T मतलब वहाँ पे तीन सेम लेवल का एनर्जी रहते हैं, इसलिए उसके T, और ऊपर जो एक्साइटेड हो जाते हैं वहाँ पे दो सेम लेवल के एनर्जी रहते हैं, इसलिए उसका नाम होता है E. ठीक है, सो दिस वी हैव ऑलरेडी, आई हैव ऑलरेडी डिस्कस्ड यू अर्लियर. नाउ लेट्स प्रोसीड. तो इसका एक टर्म सिंबल्स भी अगर आप कर लेते हो तो क्या हो सकता है तो इट विल टर्न आउट टू बी -2 -1 0 +1 +2. So when it is low spin, so you are considering the low spin d6 metal ion. तो यहाँ पे कितना हो जाएंगे 1 2 6. सो ओवरऑल अगर इसका वैल्यू कैलकुलेट करते हो तो आपका मॉड वैल्यू कितना हो जाएंगे, यू हैविंग 2 इलेक्ट्रॉन्स विद एनर्जी लेवल -2 प्लस 2 इलेक्ट्रॉन्स विद एनर्जी लेवल -1 प्लस 2 इलेक्ट्रॉन्स विद एनर्जी लेवल 0. So this will turn out to be 6. So I have already discussed with you, when the value is S, P, D, F, G, H, I, the corresponding values for I will be 0, 1, 2, 3, 4, 5, 6. तो मेरा कितना आया, मेरा अभी यहाँ पे आया 6. ठीक है, तो this will be represented by I. Clear? Since the number of unpaired electrons in this case is 0, n is equal to 0, and therefore 2s plus 1 will turn out to be 2 into 0 plus 1, which is also equal to 1. So इसका जो term symbol हो गया ये है 1i. तो अभी हमें डिस्कस करना है ये 1i कैसे स्प्लिटिंग होता है. सो दिस इज वेरी इंटरेस्टिंग एंड मैं कोशिश करूंगी आप लोगों को डिटेल में समझाने के लिए. तो पहले हम T2G, तो ये जो हमें लो स्पिन, दे आर आस्किंग फॉर लो स्पिन D6 इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ द मेटल आयन. तो कितना हो जाएंगे, सो जब लो स्पिन ऑक्टाहेड्रल फील्ड में होगा तो डेफिनेटली आपको पता है ये हो जाता है T2G EG. तो जब ये लो स्पिन है 1 2 3 4 5 6, तो इलेक्ट्रॉनिक कॉन्फ़िगरेशन विल टर्न आउट टू बी T2G6. So this is the ground state for the low spin. So this is the ground state. क्लियर? सो यहाँ पे आप देखो ये आपका T2G है, यहाँ पे भी आप लोगों को समझ में आएगा, यहाँ पे 3 डिजेनरेट ऑर्बिटल्स है इसलिए इसका नाम T2G है. यहाँ पे 2 डिजेनरेट है इसलिए इसका नाम EG है. G इसलिए बिकॉज ऑक्टाहेड्रल ज्योमेट्री इज अ सेंट्रोसिमेट्रिक geometry, and that is why the Jared subscript is used. So in this case you can see in this ground state electronic configuration you can see that all the 3 orbitals are completely filled. Therefore it can result only one arrangement. यहाँ पे एक ही arrangement हो सकता है. यहाँ पे एक ही arrangement possible है. Clear? As a result of which यहाँ पे since it is 1, so it will, the name derived will be A1. ठीक है, so overall ground state आपका क्या हो जाएंगे, so therefore ground state का term symbol क्या हो जाएंगे, A1, since this is octahedral and octahedrals are centrosymmetric in nature, इसलिए Jared subscript will be used, and since it is coming from this plus I is getting splitted, the multiplicity we have to write as 1. So this is the ground state term symbol and the lowest energy level when the one I will get splitted into. तो ये तो हमें इजीली समझ में आ गया कि ग्राउंड स्टेट का 1A 1G होता है. And what about the first excited state configuration? So what will happen? So this is very important. ध्यान से देखो, first excited state configuration. तो first excited state क्या होगा? So this is your T2G. One second, students. So this is your T2G and this is your EG level. Clear? तो first excited state में one electron will get excited to the higher energy level EG. Now ये जो one electron है, you can also say that one hole is created due to this. So either you can say that one electron got excited to the high energy level EG, as a result of which यहाँ पे one hole is getting created. And since we know that T2G is comprising of dxy, dyz and dzx, तो ये जो excitation हो रहा है from this, ये कोई भी d ऑर्बिटल से हो सकते हैं, ठीक है, वो dxy से भी हो सकता है, dyz से भी हो सकता है, ये dzx से भी हो सकता है. तो it can occur, the hole may occur in any of the three orbitals. So as a result of which इसका probability जो हो जाएंगे, इसका probability हो जाएंगे हो जाएंगे 3. Clear? Now corresponding to each assignment of the hole, the EG electron may be placed in either of the two orbitals. ठीक है, यहाँ पर भी आप जानते हो क्या होता है dx square minus y square and dz square. So ये जो इलेक्ट्रॉन ऊपर एक्साइटेड हो गया है, तो यहाँ पर भी प्रोबेबिलिटी हो सकता है, either it can get excited to dz square or to the other degenerate orbital, that is dx square minus y square. तो यहाँ पे कितना probability हो गया? Since there are two orbitals, so corresponding to each assignment of the hole, the EG electron may be placed in either of the two orbitals. So as a result of which इसका probability हो जाएंगे 2, because ये कोई भी दो EG levels में, दो d orbitals में प्लेस्ड हो सकते हैं. सो एज अ रिजल्ट ऑफ विच आपका ओवरऑल जो टोटल प्रोबेबिलिटी है वो आपका बन जाएंगे, therefore तो आपका टोटल प्रोबेबिलिटी क्या बन जाएंगे, therefore द टोटल प्रोबेबिलिटी will turn out to be, by formula मल्टीप्लाई करते हैं 3 into 2 6. ठीक है. Now the next, now since आपका probability 6 बन गया, so this 6 can be written as 3 plus 3. It means it can be written as a summation of sum of two triplet terms. So दो ट्रिपलेट टर्म्स आ गए. So मैंने क्या कहा था, ट्रिपलेट मतलब है T. So दो ट्रिपलेट आ गए, T1 and T2. So you can see, since the total probability is 6, which can be depicted as a summation of two triplet terms, T1 and T2. Since ये octahedral है, centrosymmetric है, G, और इसका जो टर्म जो splitted हुआ था वो 1I से हुए थे. So आपको multiplicity 1 हो जाएंगे. So very easily you can see that this 1I, it got splitted into the ground state. आपका क्या था, A1G1, then the two excited state जो है T1G and the T2G1. I hope this is clear to all of you. Therefore, the transition can take place from the ground state to the next excited state. Therefore, the transition can definitely take place from the ground state to the excited state. तो ground state क्या है? अच्छा, हमेशा transition क्यों ground state से ही होता है? This is very important. I know you must be knowing that ground state is the most populated state. इसीलिए कभी भी transition होगा, it will always take place from the ground state to the excited state. So overall, you are having two excited states, that is, they are having the same spin multiplicity, so that is why it is spin allowed transition है ना, and from the second excited state, as a result of which you are getting two transitions. Which are spin allowed transitions because the multiplicity in both the cases are same. ठीक है, as a result of these two transitions, you will be getting two peaks. So this is the modified orbital diagram that I have done for you all. So this is the modification of the orbital diagram for both d6 octahedral configuration to include the singlet states arising from the free ion terms. ठीक है, now see, ये पहले हमने जो यहाँ पे किया है, and this 5d is due to the high spin octahedral d6, and this is due to the low spin octahedral d6. This is the low spin, and it resulted to the term symbol of 1i. So it is clearly visible to you that for the high spin, it got splitted into 5T2G and EG, as a result of which there is only one transition. So high spin के लिए मेरा जो transition हो गया, so for high spin मेरा जो transition हुआ है from the ground state T2G to the excited state EG. That is why you got only one transition. Due to one transition, you also got one peak. And in the case of low spin, it is very much visible to you that this 1i will now get splitted into the ground state term A1G, and it will result into two excited state. ठीक है, तो फिर आपका ये क्या हो जाएगा? This will turn out to be for the low spin. So आपका हमेशा transition कहाँ से होता है? From the ground state A1G से ही transition होगा to the next excited level, this, and also A1G to the next excited level. Okay, so यहाँ पे this will be 1. ठीक है, ये 1 T2G होगा. ठीक है, so it will result to two transitions. It will give two peaks. So therefore, let's see answer में options क्या क्या है. Obviously, D6 high spin के लिए हमारा 1 था, and low spin के लिए हमारा 2. So answer is 2. I hope this is clear to all of you. मैं एक बार recapitulate कर लेती हूँ आप लोगों का, especially this low spin. देखो, मैं फिर से बताती हूँ, ये जो low spin है, तो इसका क्या है? इसका जब ग्राउंड स्टेट था, तब इसका एक ही अरेंजमेंट पॉसिबल था, जहाँ पे T2G सब T2G कंप्लीटली फिल्ड है. आप इसका कोई दूसरा अरेंजमेंट नहीं कर सकते हो. सो ड्यू टू वन अरेंजमेंट इसका जो टर्म बन जाते हैं A1. A मीन्स 1, सो इट इज 1. तो A1 हो गया, स्पिन मल्टीप्लिसिटी है 1, तो इसका जो ग्राउंड स्टेट टर्म सिंबल है वो है A1, 1 A1G. जब फर्स्ट एक्साइटेड स्टेट, मतलब एक इलेक्ट्रॉन जब एक्साइटेड हो गया है, नाउ जब फर्स्ट एक्साइटेड स्टेट कॉन्फ़िगरेशन जो है, जब एक इलेक्ट्रॉन एक्साइटेड हो चुका है, तब एक इलेक्ट्रॉन फ्रॉम द T2G लेवल से EG चले जाते हैं. नाउ यहाँ पे आप बोल सकते हो दैट ये जो 3 डिजेनरेट ऑर्बिटल है ये इलेक्ट्रॉन कहीं से भी जा सकते हैं, dxy से भी, dyz और dzx से। तो यहाँ पे जो होल मैंने आप लोगों को दिखाया ये होल कहीं पर भी क्रिएटेड हो सकता है, एज अ रिजल्ट ऑफ विच इसका प्रोबेबिलिटी 3 है, बिकॉज it can result in the formation of the hole in any of the 3 orbitals। किसी में भी probable इसका होल बन सकता है, इसका probability 3। so after it gets excited यहाँ पर भी एक probability का क्वेश्चन आ जाता है that ये 2 orbitals में से किसी एक में आ जाते हैं, so as a result of which is resulting in the probability of 2। therefore by formula the total probability will turn out to be 6। as because ये 6 है total probability, so this can be written as 6 is equal to 3 plus 3। 3 मतलब triplet degenerate t हो जाते हैं, ठीक है। and the total it means 3 plus 3 means it can be written as a sum of 2 triplet terms, ठीक है। excited state जो है तो एक t1 हो जाता है, दूसरा t2, since it is और ऑक्टाहेड्रल तो जेड सब्सक्रिप्ट इज यूज्ड, और इसका ऑलरेडी स्पिन मल्टीप्लिसिटी हम लोगों ने दिखा दिया 1 है। तो आई होप दिस इज वेरी मच क्लियर टू यू दैट यहाँ पे जो टर्म सिंबल हमें 1i मिला, इट गॉट प्लेस्ड इनटू द ग्राउंड स्टेट टर्म a1g and the 2 excited triplet terms t2 and t1, as a result of which it will result in the spin allowed transitions from the ground state to t1g and from the ground state to T2G. So it will result in 2 transitions. So this is the proper explanation of the modified orbital diagram. This I have taken from the book RPS. For reference, you can obviously have a look over there. So you will be very much confident once you go through the reference book itself, and I have given you the best explanation. I hope you like your video. If you like, do press the like button. Thank you for watching our video. Thank you.